differentiation, the quotient rule. So the quotient rule is needed if we have an equation in the form y equals u over v, where u is one expression and v is another expression. And the formula is v du by dx minus u dv by dx all over v squared. So in this question we want to differentiate y equals x cubed over cos x. We've got the u expression, which is x cubed, and the v expression, which is cos x. So first thing we want to do is write it out. So we've got u equals x cubed and v equals cos x. Secondly, we want to differentiate these two expressions, so we'll have du by dx equals 3x squared and dv by dx, which equals minus sine x. Next we want to follow this formula, so we're starting with v multiplied by du by dx. So v, which is cos x, multiplied by du by dx, which is 3x squared, minus, and I'm going to put this term in brackets because this will make life clearer later on, and then u multiplied by dv by dx. So u, which is x cubed, and dv by dx, which is minus sine x. Close brackets. All over v squared. So we've got cos x all squared. Next, to make this a little bit nicer, I'm just going to write it in a nicer format. So we've got 3x squared cos x minus x cubed sine x all over cos squared x. Simplify it again with these two negatives. Now there's a few different routes we can go down to simplify this. You may even need to use trig identities. We could go down the route of taking out a common factor on the top. We could even separate the two terms on the top. So there's lots of routes you can go down at this point. It may specify in the question, but just be careful and keep an eye on that. But as far as we're aware, we've left it in this form here without going into trig identities and left it in a fairly nice form. So here's two questions you can have a go with. I've left the quotient rule on screen as well as the table of derivatives. Pause the video and resume again when you want to go through the answers. So for the first one, we've got u equals 3x to the 4 and v equals sine x. So u dash equals 12x to the 3 or 12x cubed and v dash equals cos x. We've got our quotient rule down here. So we've got v, which is sine x, multiplied by du by dx, which is 12x cubed, minus u, I'm going to put all this in brackets again, so 3x to the 4, multiplied by dv by dx, which is cos x, all over v squared. So we've got sine x squared. Again, trying to simplify it down to a nicer form, but firstly I'm just going to make it look a little nicer. So 12x cubed, lots of sine x, minus 3x to the 4, lots of cos x, all over sine squared x. What I'm going to do at this point is take out a common factor from the top. So a common factor is 3, and a common factor is also x cubed. So if I take out a common factor of 3x cubed, then we're left with 4 sine x minus x cos x all over sine squared x. And we'll leave our answer in that form. Again, you may need to use trig identities, but for the purpose of this question, we've used the quotient rule. For the second question, we've got u equals 2x cubed plus 4, and v equals x squared minus 4. So u dash equals 6x squared, and v dash equals 2x. So this should look a little bit nicer. So we've got v, which is x squared minus 4, lots of du by dx, which is 6x squared, minus, all in brackets, u, which is 2x cubed plus 4, multiplied by dv by dx, which is 2x. all over v squared, which is x squared minus 4 all squared. Again, I'm going to make it look a bit nicer because it makes it easier to simplify it. So we'll have 6x to the 4 minus 24x squared minus 4x to the 4 plus 8x all over x to the 4 minus 8x squared plus 16. That's it expanded and simplified. Then we'll simplify the top. So we've got 6x to the 4 minus 24x squared minus 4x to the 4 minus 8x all over x to the 4 minus 8x squared plus 16. We can simplify the x to the 4 terms. So we'll be left with 2x to the 4 minus 24x squared minus 8x all over x to the 4 minus 8x squared plus 16. We're not going to be able to simplify that down any nicer, so we're going to leave it there. So that's it for the quotient rule. Feel free to check out my other differentiation videos. Stay safe and healthy out there, and I'll see you in the next video.